Hello everybody, welcome to Mathematics for Programming course. In this video, I'm going to discuss Boolean algebra for computer programming. So Boolean algebra is a mathematical system used in computer programming to handle binary values. The binary values can be true or false, or ones and zeros, okay? And it is fundamental to logic operations, decision making, and control flow in programming. So I will talk about some subtopics of linear algebra and their application in programming. The first one to discuss is the Boolean variables. So it means the variables that stores either true or false or 1 or 0, okay? So how can we use them? We can use them in the control flow in conditional statements, for example in the if statements or while statements. We can also use them to track program states. For example, if the program is running, I can say it's running equals true, or if the condition is valid, I would say it's valid equals true. And I can also use them to simplify logic in algorithms. And let us see how we implement Boolean variables in Python. So let us see the program here. So the idea is rather simple. I just assign true or false into the two variables. So remember that for Python, true and false would start with a capital letter, okay? And if this one is true, I will print this one out. If the variable here is not true, that means if it is false, I'm able to show this out. So let us see the result. Okay, you can see that I'm able to print the two sentences here, okay? Because for the first one, it is true, and for this one, not false becomes true. So it means that this one is also true. That's why I'm able to print the second statement as well, okay? The next topic to talk about is the Boolean operations, which means we have AND or NOT operators. So we can join the Boolean variables by using AND or NOT operators, okay? So if we see the word AND, it means that if both operands are true, that means if we have two true values joined together with the AND operator, I will have true. For the OR operator, it means that if at least one of the two operands is true. So this is the meaning of the OR operator. And for the NOT operator, it is just doing the inversion of the original truth value. So true to false or false to true, okay? And we have to notice the precedence of operating these three operators. NOT comes first, AND comes next, and OR comes finally. That means if we see NOT, we do the NOT first. If we see AND, we do AND first. If we see OR finally, we do OR in the later stage. So this is the situation when we don't provide the brackets to tell the order of operations explicitly. So if we have no brackets, we would follow the precedence shown here, okay? And how about the applications of Boolean operations? We can use them to combine conditions in control structures. We can use them to filter data in queries or loops. We can also implement logic gates in hardware simulation or low-level programming by using AND or NOT operators. So let us see how we can implement Boolean operations in Python. So here, X is true, Y is false. If I join the two operands with the AND statement here, I will try to see if X is true and not Y is true. If they are both true, then I will be able to do the printing here. So you see, not Y here means not false, but not will come first in the precedence. That's why I would do not Y first before I go to the AND comparison. So X is true, not Y is also true. True and true would allow me to do the printing. And for the OR operation here, true or false is also true because at least one of the operands has to be true in order for the OR operation to return true, okay? And for NOT operation, I would just need one operand here. So not false here is true, so this part will become true. So I will be able to print out all these three statements. Let us see the result. Yes, all these three things will be printed out because the result will be true for all these situations, okay? So let us talk about the truth tables. So for the AND or NOT Boolean operators, they have their own truth tables. So the sentences here can be summarized by means of the truth tables. So a truth table is a table that shows the output of a Boolean expression for all the possible input combinations. So suppose I have two inputs for each of the AND or NOT operators. If the first one is true, the second one is true as well. For the AND operation, I will have true. So if any one of the two inputs is false, I will have false as the answer, okay, for the AND operation. And for the OR operation, if I have at least one true value in the inputs, I will have true. So when both inputs are false, I will have false as the answer. And for the NOT operator, it is easy. I just do the inversion of my given single operand. Okay, true would become false and false would become true. Okay, how will we apply the truth tables? We can use them to design and verify logic operations for algorithms or circuits. We can also use them to help us debug complex conditional statements. And we can also use them to simplify expressions in optimization problems. How can we use Python to make a truth table? Let us see this example here. So I want to simulate a truth table for AND operations. Okay, so I would like to try all the permutations of A and B. So A can be true or false, and B can also be true or false. So if I pick up true and true, I will have the result being true. If I have true and false, the result will become false. So I want to try all the possible values in A and all the possible values of B, and then I put both of them in this operation A and B to see the result. So let me try to run it. Yes, I'm able to print out the truth table. When A is true, B is true, I will have true as the answer to A and B. Only if A and B are true, I will get true. Otherwise, I will have false as the answer, because at least one of the inputs will be false. Okay. So the next topic to discuss is the Boolean expressions. So what is a Boolean expression? It is a combination of Boolean variables and operators forming a logical statement. So how can we use them? We can use them in evaluating conditions in if statements, elif statements, and while statements. Okay. We can also use them to implement search filters or validation rules. We can also use Boolean expressions to simplify complex logic in decision-making algorithms. So let us go straight to the program to see how we handle the Boolean expressions. So we have two variables, age equals 25, and has license is a Boolean variable which is true here. So I can use this one to do the assignment. I want to see if my age is 18 and if I have a license or not. If both conditions are satisfied, I would just assign true to the CanDrive variable. Okay, so I can use the Boolean expressions to really see the combined result. Okay, so this combined result will be saved in this variable called CanDrive. And if this is true, I'm able to show this printing statement here. So let us see the result. Yes, you can see I'm able to print it out because both conditions are satisfied. Okay, so we have a Boolean expression here. I assign the result of the AND operation to a variable. Okay, and let us talk about another concept called De Morgan's laws. There are two such laws of De Morgan's laws. The first one is like this one. If I negate A and B, it is equal to not A or not B. So it is equal to doing the negation of individual truth value, and I take the OR instead of using AND. Okay, and the other one is like this one. If I negate A or B, it is equal to not A and not B. Okay, so I negate individual truth values, and then I take the AND operation. Okay, that is the meaning of the De Morgan's law. So what is the application of using the De Morgan's law? We can use them in simplifying the complex Boolean expressions in our code. Also, we can use them to optimize the conditional logic for more efficient performance. We can also use De Morgan's laws to help us refactor the code for readability. So let us see how we can implement the De Morgan's law in Python. Now let us see this example. Suppose A is true and B is false. If I want to apply the De Morgan's law, which is the first law on my notes, I'm just typing the left-hand side on result 1 and the right-hand side on result 2, okay? So we already know from point number 1 that not A and B here is equal to not A or not B. So here A and B will be handled first because I have a pair of brackets to denote the order of preference, okay? And for the not A and the not B here, I also add the pair of brackets for clarity, okay? So we handle this part first, followed by this part first, before I put them into the OR operator, okay? So you can see that I want to see whether the two truth values will be the same or not. So we will expect that the result will be true because according to the De Morgan's law, result 1 will be equal to the result 2. So let us see if it is really the case or not. Yes, we will see true here. This means that I'm able to verify the De Morgan's law by using a typical example here. So A is true, B is false, and I will be able to get both true after either the operation on the left-hand side or the operation on the right-hand side, okay? So A and B is just false, and not false is true. Not A is false, and here not B is true. So false or true is of course true according to the truth table of the OR operator, okay? Now let us talk about another topic called bitwise operations. What does it mean by bitwise operations? Let us see the following definition. We have a number of operations shown here. They can manipulate individual bits of integers based on the Boolean algebra. So this is the bitwise AND operator. This is the bitwise OR operator. This is the exclusive OR operator in bitwise sense. And this is the inversion of bits, which will return a negative number by using the 2's complement notation. And this is the left shift of bits operator, and this is the right shift of bits operator. So let us see this example here. So suppose I have A as 5 and B as 3. So we can see that the binary representation of number 5 will be 0, 1, 0, 1. And for the bitwise representation of number 3, I will have 0, 0, 1, 1. Okay. So for the bitwise AND operator, I need to check the operations bit by bit. So 0 and 0 here will be 0. 1 and 0 will be 0. 0 and 1 will also be 0, and 1 and 1 will be 1. So only the final bit will become 1, and all other previous bits will be 0. Okay, so here 0b means I use a binary number representation. Okay, and for the OR operator here, it is the bitwise OR operator with just one vertical line. So we can see here 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, 1 or 1 is of course 1. That's why I have 1 0 followed by 3 1s. That's why I have 7 in decimal number. And this is the exclusive OR operator. When we have the same bits, I will have 0. And when I have different bits, I will have 1. So same bits, same 0 here, 2 zeros here, I will have 0. 1 and 0, so I will have 1 and 0 here. That's why I will have 1 here, because the two bits are different. And 0 and 1 combined together will have 1, because I have two different bits. And for 1 and 1 here, I will have 0, because the two bits are the same. That's why I will have 0, 1, 1, 0, which is 6, okay. And for the inversion of bits, for A here, I will have 1, 0, 1, 0. And in 2's complement, I will be able to get -6, okay. And for the left shift here, you see that I have 1, 0, 1 for the rightmost 3 bits. So when they are all shifted to the left, I will have 1, 0, 1, and I will have 0 missing on the right-hand side. That's why when I add the empty 0 here, I will have 1, 0, 1, 0, which will become 10 in the decimal number system. Similarly, for the right shift operation, I'm able to have 0, 0, 1 on the far right, and the empty bit here is replaced by a 0. That's why I will have 0, 0, 1, 0, which will become 2 according to the decimal number representation. So that is the meaning of the left shift and the right shift operations. So how can we apply the operation of bits? We can use them in low-level programming, for example in embedded systems or device drivers. Or we can also use them to optimize the storage and computation. For example, we can use bit masks to do so. Also, we can use the bit operations in cryptography and data compression algorithms. So let us see how we can implement the bitwise operations in Python. So here I have an example. A is 5, B is 3, and then I can just do the bitwise operations using AND, OR, exclusive OR, and NOT. So here, NOT means that I'm able to reverse all the bits inside a binary number, okay? So let us see what will happen. Okay, you will see those answers coming out. So the idea is to convert the binary number obtained after the bitwise operations back to the decimal number system, okay? So that's why I will have 1 and 7 and 6 and -6 according to the binary to decimal conversion. And here for the last one, I used the 2's complement to do it, okay? That's why I will have a -6 here when I do the 2's complement of this set of bits obtained by inverting all the bits in A, okay? Now, let us see another point of Boolean algebra, which is called the Boolean algebra in logic gate simulation. So we can use the basic operators AND, OR, NOT to produce other logic gates. For example, we can use them to create the NAND gate, NOR gate, and the exclusive OR gate. And they can be used in digital circuits. The first example is the NAND gate, which is just the negation of the AND result, okay? So if I have input 1 as true and input 2 as true, originally I will have true and true, which is equal to true, but I just negate the true result to become false. Similarly, I will have the 3 remaining lines as follows. True NAND false will become true, false NAND true will become true, false NAND false would become true. Okay, that is just the opposite of the AND gate, okay? The result will just be the opposite of the original AND gate, okay? Similarly, for the NOR gate, it is just the result obtained by negating the result coming from the OR gate. So true or true will be true originally, but if I do the negation of the result, I will have false. Okay, so similarly, I can have the following 3 lines. True nor false will become false. False nor true will become false. False nor false will become true, okay? And for the exclusive OR gates, it is just checking whether the 2 inputs are the same. If they are the same, the result will be false. If they are different, the result will be true. So true, true will become false because the 2 inputs are the same thing. So first, true exclusive OR true will become false because true, true here are the same inputs. That's why I will have false here. True exclusive OR false will become true because the 2 inputs are different. That's why I will have true here. Similarly, false exclusive OR true will become true because the 2 inputs are different. False exclusive OR false will become false because you can see that the 2 inputs are the same thing, which is the false here. So we will see an example of implementing the exclusive OR gates in Python. And the application of the logic gates can be these things. We can simulate the hardware behavior and software, or we can use the logic gates to design algorithms for circuit simulation tools. We can also use the logic gates to help us debug digital systems in embedded programming. So let us see how we can implement the exclusive OR gates in Python. So here is the way to simulate the exclusive OR gates. The exclusive OR gates can be simulated by using this line of the logic operations. A or B first, followed by AND, NOT, A and B. So take care of the brackets. So A or B will be done first, and A and B will be done next. After that, I will take the negation of the second operation in brackets, and then I will just put the first result to the AND gate, And the second result coming from the negation here will also be put into the AND gate to do the operation. And that's the result equivalent to using an exclusive OR gate. Of course, you can use a truth table to check the validity of the statement here to see if it is equal to the exclusive OR gate. Okay, so let us see the result here. If I have true and false as the two inputs, I will have true because you will see that the two inputs are different. If the two inputs are the same, like true, true here, I will have false. So let us see if it is the case or not. Yes, you will see that I'm able to see true and false respectively. Okay, so remember that the exclusive OR operation can be simulated by using this long expression here. Okay. Now let us talk about the final part of the course, which is called short circuit evaluation. What is the meaning of the short circuit evaluation? Let us see the definition here. In AND and OR operations, Python would stop evaluating as soon as the result is determined. So if we see the false in the AND operation, or if we see the true in the OR operation, we will already be able to say that the result here will always be false, regardless of the truth value of the other input. Same for the OR operation here. If the first input is already true, I'm so sure that the result will be true, regardless of the value of the second input. Okay. So let us see the example here. Suppose I have a function here, and x is false. So if x and that function, which is returning true all the time, you will see that this line will never be printed out because x here is already false. So regardless of the value of the second input of the AND operator, I'm already able to refute the printing here because this statement x and expansive operation will always be false because the first one is now false. Whether or not the second input is true or false, the collective result will always be false. Okay, so I'm able to show that if the first input is false, I don't really need to check for the truth value of the second input here. Okay, so I've just shown end of program. That's why I've just skipped the printing shown in the if statement. Okay, so we will show the end of program print out straight away. The reason is just like that. As x is already false, the combined result of the AND statement here, it will be immediately false without ever checking the result coming from the second input called expansive operation. Okay. And how can we apply the short circuiting in programming? We can use it to prevent unnecessary computations or errors. That means we can avoid division by zero by using this approach. If the divisor is 0, we can just skip the entire division because we cannot use 0 as a divisor. Okay. And we can use the short-circuiting evaluation to improve the performance in conditional checks. Just like the example shown here. We can use the short-circuiting to help us do the conditional check. And we can also use the short-circuiting to simplify the code with the conditional expressions. So how can we implement the short-circuit evaluation in Python? Let's see the example here. So we have an example here. X is 0 and y is 10. We can use the short-circuit mechanism to prevent division by 0. So let us see here. I want to check whether y divided by x is larger than 2. But of course, x can be 0 if I don't restrict the value of x to be input. So I have to really check whether x is equal to 0 or not. If x is 0, I'm not able to make the program to run smoothly because division by 0 will result in a runtime error. Okay, so that's why I have to check whether this 0 will be existent in the divisor. Okay, so if x is really 0, which means that the divisor is really 0, I will just go to the second part here. That's why I can use the short circuit evaluation to help us check for the situation that is possible to produce a runtime error. Okay. That's why I can use the short circuit evaluation to help us avoid the situation of happening a runtime error. Okay. So let us see the result. yes, you will see that I'm able to print the second line here coming from the else part. So this else part can be achieved because I'm not really able to reach the part that will result in a runtime error. Because if I have already known that the divisor is 0, I don't ever really need to go through the second part of the end statement. So this part will not be run. That's why the program will not result in a runtime error. Okay, and if it has no runtime error, it can just go to the else part very smoothly. Okay. So we can see that we have discussed a number of things about Boolean algebra for computer programming. First, we discussed the Boolean variables, which can be either true or false. And we also handled the Boolean operations. The basic ones are AND or NOT operations. We also know that the order of precedence will be like that, NOT and OR. So we have to check the precedence in this order. Also, we know the truth tables. We have the basic truth tables for AND or NOT operations. Okay. Also, we have seen some Boolean expression examples. Okay. And we also handled the De Morgan's law, which is just the 2 lines here. Okay. And we also handled the bitwise operations to handle the bits 1 by 1 by simple comparison according to the respective bits. Okay. We also handled the Boolean algebra in logic gate simulations. That's why I would have NAND, NOR, and exclusive OR operations produced by using the basic AND or NOT operators. Okay. And finally, we have the short circuit evaluation, which means that Python will stop evaluating as soon as the result is determined without even handling the second truth value of an AND or operation. This is the end of the video. If you have any questions about my video, please leave your questions on the comment section below the video. If you like this video, please give me a like and please subscribe to my channel. Thank you for watching.